56 years. Every star atlas wrong. A globular cluster. Ancient, uniform, unremarkable. Break time. 600 miles. Abel's mirrors cut through 12 billion years of dust. The gravity matrix. What Webb found inside Terzan 5 was not a cluster. Here at the gravity matrix, this Webb dataset stopped us. Hubble's 2016 results, but infrared changed everything. The Milky Way hid this since the universe was young. A fossil from our galaxy's violent birth rewrites everything. Today's investigation begins where Agot Terzan left it in 1968. Agot Terzan catalogued it in 1968, moved on. Globular clusters were well understood, one ancient stellar population. All stars born simultaneously from the same primordial gas cloud. Same chemistry, same age. One frozen moment in time. That rule held for every cluster, until Terzan 5. Terzan 5 sits 22 light-years away in Sagittarius, buried in the Milky Way's central bulge, obscured. Optical telescopes couldn't see through. The dust was impenetrable. For decades, Terzan 5 yielded incomplete data. Something was off. In 2009, two distinct stellar populations emerged from the data. First hint Terzan 5 was breaking globular cluster rules. Hubble measured age differences between the populations in 2016. The age gap was staggering, billions of years apart. Two populations could still fit a complicated cluster model. The physics community needed deeper data. They needed James Webb. Webb's NIRCam instrument operates at wavelengths dust cannot block. Giorgia Zullo at the University of Bologna led it. Zullo's team merged Webb infrared with Hubble's 12-year data. Proper motion measurements isolated true Terzan 5 members. What emerged from that combined dataset was impossible to dismiss. Not two populations, not three, four distinct stellar generations. The investigation now enters its first thread, the ages themselves. Generation 1, 12.5 billion years ago. The Milky Way assembling, among the first stars forming in our future galaxy. Generation 2, 4.7 billion years ago. Solar system unborn. Generation 3, 3 billion years ago. Earth's first life. Generation 4, 2.5 billion years ago, the most recent. No standard globular cluster contains more than one generation. None. Direct observation. Peer-reviewed in Astronomy and Astrophysics. Not a preprint, not preliminary. Published and confirmed. Professor Francesco Ferraro built the observational case across 2 decades. Ferraro's team noted something extraordinary about the iron content. Each successive stellar generation was more iron-rich than the last. Normal globular clusters cannot do this. They cannot self-enrich. Their mass is too small, supernova ejecta escapes. Terzan 5 was different. 2 million solar masses held iron. Retained iron cooled into new gas clouds. Raw material. Approximately 10,000 Type II supernovae detonated inside Terzan 5. Each deposited heavy elements that built the next generation. R. Michael Rich at UCLA, a fossil record. Iron. That phrase deserves pause. A fossil record. Written in starlight. The second investigative thread, neutron stars. Thousands of them. Every enriching supernova also left a neutron star behind. Terzan 5 contains an unusually large millisecond pulsar population. These pulsars are the neutron star legacy of Terzan 5. How does anything survive 12.5 billion years? The galactic bulge is brutal. Tidal forces shred structures. When Terzan 5's first stars died, 10,000 supernovae. 2 million solar masses held the ejecta. Exceptional gravity. Retained iron-seeded new clouds. Generation 2 ignited later. Self-enriching fossil. The Milky Way mixed all. Terzan 5 remembered. Third investigative thread: what the survival means for galaxy formation. The early universe was not smooth, galaxy formation violent. Simulations show gas disks fragmenting into clumps migrating inward. Those clumps merged to form galactic bulges, dense regions. Most primordial clumps were destroyed in the merger. Ferraro's team described it like mixing cake batter. The Milky Way mixed everything thoroughly. One lump remained. Lanzoni at Bologna. This explains how all galactic bulges formed. Every spiral galaxy assembled its bulge this same way. From that process, we found exactly 2 survivors. 2 out of hundreds in the galactic bulge. That number demands attention. The universe kept almost nothing. No model has answered. Why did Terzan 5 survive? Ferraro, this clump formed separately and was not destroyed. Honest science, the investigator admits what remains unexplained. 3 competing explanations exist for Terzan 5's survival mechanism. Hypothesis 1. Mass alone placed it above disruption threshold. Hypothesis 2. Its orbit avoided the most dangerous passes. Hypothesis 3. A dark matter subhalo provided additional gravitational protection. The data does not yet distinguish between these explanations. The most significant galactic archaeology dataset of the decade. Not because it is unusual, because of what it witnesses. It witnessed the Milky Way's full assembly and survived. Zullo's AAS 248 analysis in Pasadena deserves emphasis. The methodology combined NIRCam infrared photometry with proper motion filtering. NIRCam operates at 0.6 to 5 microns, deep infrared. At these wavelengths, dust becomes transparent. Hidden becomes visible. Hubble's 12-year baseline measures proper motions to isolate true members. Stars moving together, Terzan 5. Differently, background noise. This methodology eliminated background contamination from the galactic bulge population. We saw the clean dataset and verified the methodology twice. 4 populations. Independent confirmation from both instruments. The result held. The uncertainty is not whether 4 populations exist. They do. The uncertainty is the survival mechanism. That is what matters. This is the paradigm-shifting moment. The reclassification changes a category. 56 years, globular cluster was sufficient. Not anymore. JWST enabled not just discovery here, it is resolution. Webb resolved what Hubble measured but could not characterize. The framework, Hubble's 12-year baseline, Webb's infrared vision. How many fossils from the Milky Way's violent birth? Only 2 confirmed, Terzan 5 and Liller 1. Liller 1 was similarly reclassified, also multi-ion, also multi-age. The Bologna team now examines 40 to 50 bulge clusters. Early galaxies had fragmented disks. Massive clumps sank inward. Most were destroyed. 2 survived exceptional mass. Every spiral galaxy likely went through this formation process. Terzan 5 may be our only window into that process. What this means at cosmic scale changes everything. If bulge clusters show multi-age populations, the category widens. If the survey finds none, Terzan 5 more anomalous. Either outcome advances our understanding of galactic archaeology significantly. Zullo's work is consequential. The question is now testable. Now the resolution. What does this mean at larger scale? Galaxies like ours did not form smoothly. They assembled violently. Uranium was forged in objects like Terzan 5. 10,000 Terzan 5 supernovae forged iron across the galaxy. Some iron entered our solar system's formation disk. You are, chemically, a direct product of galactic archaeology. The Milky Way assembled through violence, Terzan 5 the scar. It survived massive enough to hold itself. It remembered. What does 1 generation later look like for this discovery? Roman Space Telescope launches in the late 2020s. Wider infrared. Roman can survey the galactic bulge, thousands of clusters. If Roman finds 50 fossil fragments, category is fundamental. If Roman finds only 2, Terzan 5, Liller 1. Other result is extraordinary. This is the framework to watch. We do not yet know. The uncertainty is most interesting. Agop Terzan catalogued this in 1968. Called it a cluster, working at the edge of what technology could see then. He worked to the resolution limit of his generation's instruments. Science corrects through better data, not failure, the process. 56 years calling Terzan 5 a cluster, not wasted. Those measurements provided the proper motion baseline proving reclassification. Every observation by astronomers studying what they called a cluster was building the dataset that exposed the truth. But what matters most here isn't the generations themselves. We now have a testable proxy for the unobservable. Early universe galaxy formation, too ancient for direct observation, Terzan 5 preserves that history, accessible 22,0 light-years away. Geologists read rock strata. We now read stellar strata. Ancient stellar iron was deposited by supernovae, like sediment. Each generation's chemistry records its era's supernova signatures. Those signatures date each generation to within millions of years. A few 100 million years sounds imprecise. Galactic scale, extraordinary. In cosmic archaeology, fingerprint-level identification of a formation event, please call stellar, preserves what the universe rarely keeps. Zullo spent years on this dataset before Webb resolved it. When Webb's infrared arrived, the team checked for errors first. Twice. Proper motion cross-check. Peer review. Then AAS 248. That rigor is why we trust the result. The Milky Way carried a witness to its own birth. We had no idea, couldn't see the dust, until Webb. What else is the Milky Way hiding in its bulge? The gravity matrix tracks datasets that reshape our cosmic view. The next Webb bulge observation cycle is scheduled. We're watching. Full investigation pinned in the comments. Subscribe to the Gravity Matrix, track every major dataset. Roman's galactic survey begins in the late 2020s. Watch. Full breakdown pinned here when Roman bulge data arrives. Terzan 5 remembered. Watch the full investigation, link below.